persistent. Give them a big hand, please.
So the ZODB is an object-oriented database implemented in Python, optimized in C. If you want to look at the slides, if you go to pythonlinks.info/ZODB, search for slides, it's on there. The first question everyone asks is, why bother? And the answer is, if you're doing applications which are based on trees or applications which are based on graphs, ZODB makes it really easy to build these applications. So if you're doing like network security or social graphs or something, this and Neo4j, they're like graph databases. And when people say, okay, that sounds interesting, is anybody actually using it? So there's a content management system called Plone. All the Plone sites use the ZODB. ZODB is mature, very stable, really rock solid. It's been around for a long time. The big user is the Brazilian government. So they have 100 websites in Brazil, all the way from the president's office, the parliament, the local regions, 100 different websites in the Brazilian government are using it, and lots of organizations outside. There are also a lot of Pyramid users who are using ZODB, but it's not clear which of them are. So here are the pages from the Plone website about who's using it. Okay, well, that sounds interesting. But the real thing about the ZODB is it's this magical piece of software. So I don't worry about reading and defining a database schema. I don't worry about reading and writing data. I pull the root object out of the database. I attach my objects to it. They're persistent. From then on in, I'm just writing Python. I'm not thinking about the database at all. Okay, so how do you do it? So here we have an account object. We basically create an initial account object. We set the initial value to 0. We can add money to it. We can make a deposit. We can make a withdrawal. Very simple. And all I have to do to make it persistent is I subclass off class persistent. There's also a persistent, it's a persistent object. There's a persistent set. There's a persistent dictionary you can subclass off of. Very, very easy. And then, of course, you have to, okay, so what do? You have to create a database. You can create them in relational databases. You can create them on a file system, in memory. There are different ways of creating. You get a connection to the database. You pull out this root object, and then you start adding things to your root object. So the simplest way, once you have a root object, the simplest way is you create an account object, and you just say root.account1 equals that account object, okay? But in reality, you don't have a single account object. You have lots of account objects. So you create what's called a container. It looks like a B tree because it's actually stored on a file system, but to the developer it just looks like a dictionary. So it's kind of the fact that it's stored on the file system is completely transparent to you. And so basically you create one of these B trees, and then you go down and you say, first say root.accounts is equal to that B tree, and then further you create the account and assign it into that B tree with that name. Very, very easy. And of course you have to commit your transactions. Notice there's no begin transaction, there's just an end transaction. And that's because the ZODB is an optimistic concurrency control database for content management systems, for lots of applications. You're not worried about people competing much. If they do, they throw an error, you process it. But so it just makes it very simple. You just commit your transactions at the end. It's just Python. So if you want to add some money to it, you just get the root object, and from there you go into your B tree, you get the object you want, you do deposit, and you deposit. Or if you want to do a simple report, you can just iterate over the nodes in that B tree, over the nodes in that container, and just print out the key and print out what the value is. So you're just doing Python, no SQL select, nothing. And of course, it's a proper ACID database. I won't go into all the details. I don't worry about that stuff. So one of the miracle things about it is it's a version database. And so all the different tools that use it, they all use this property. The Plone is the content management system. It's the nicest, it's got the nicest interface. So you can see the different versions. Say you're submitting some content, you can go back into history, you can see the different versions, you can compare the different versions, you can restore a different version. Take something like the Jupyter notebooks, right? Right now, it's a single JSON file, but you can't do previous versions, okay? So maybe you can put the whole JSON file into a GitHub repository, and you can, back to a whole version of the different JSON file, but if you stored a Jupyter notebook in something like the ZODB, you can see the different versions of all the cells. You can see the different versions of all the subcells, and you can restore any one. We just take these things for granted as availability of versions, but the rest of the world doesn't think that way somehow. And of course, it's really easy for doing trees. So I built a directory. I wonder if you came here for the Python links talk, like we talked yesterday. I built a directory of the Python ecosystem, and so it's a tree of categories. It's a taxonomy. So very easy to do something like this on the ZODB. And of course, it does graphs as well. And of course, I do the part that people really like are my tree of companies. So I've got a region of the world, a region called Europe, a country called England, a city called London, a company called JP Morgan, and within that, you've got links to YouTube and Twitter and jobs and careers and all kinds of other information. If you're building a kind of tree-structured data model, it's so easy to do this kind of thing in ZODB. And so this is what, so people don't want to see the data structures, they want to see what the results look like. So here's the map of Python companies in London. I did a lightning talk on this yesterday, but a lot of people here weren't yesterday. This room is empty afterwards, so if you want to stay afterwards, I'll do a quick 5-minute lightning talk on the map of Python companies. I want to focus this talk on the ZODB, and you do tables, presenting tables and stuff too. Okay, so here we have, okay, so you've got a tree of objects. It can be a graph of objects, right? And how do you get to an object? Well, it's very easy to map a URL onto this tree. So if you go down one level, software, that'll take you to that one. You go down 2 levels, software libraries, database libraries. So it's very natural if you're building websites to have a tree of URLs and just map them into it. But the problem is I'm building directories, and the directories are growing and changing, and objects are moving around. So what you want to do also, what I also did is a canonical URLs. So every node in the tree has a unique name. And so I just give the domain name followed by the unique name, and that takes you to the particular node directly. So that's much cleaner, it looks much nicer. I'm surprised more people in this community haven't done this. Oh, and this is actually an example of a graph, right? So I talk about trees, but I'm already doing graphs, because to reach any node, you can either do traversal, or you can just go directly from the root, using that. So I'm actually already doing a graph database. You don't even know you're doing a graph database. And it does all the persistence properties correctly. Okay, so everyone asks, what's the difference between tree of the ZODB and a relational database? We all know about relational databases. And some things are easy in one, some things are different than the other. So in my class, I have 10 different classes in my tree. And so in any node, I could have 10 different tables. And so if I want to do that in a relational database, I have to do a join across 10 different tables. Like, it's very expensive. Right? If I do it in ZODB, I just iterate over the nodes in that thing. It's like really fast and really simple. It's all cached, no problem. On the other hand, if you want to do relational databases, they have indexes. And so it's really easy to get, for example, all the accounts with a certain balance. Whereas in ZODB, I have to build my index myself. So he goes, well, how the hell do you do that? Okay, so the first line is you basically create a catalog. And then the second one is you have to have a method to access. So this is the method that the catalog will use to access the value. And the third one is you create an index, an account balance index, and you basically say use this method. Then you create your account, and when you create your account, you have to tell it you have to tell the catalog to index it, or when you change it, you have to tell it to re-index it, and then you have a simple query object. So you actually have to create your account, your indexes yourself. There are actually some external indexes. You can also do an index. There are 2 different tools for indexing in Postgres, one which will index in Postgres text fields, and the other which actually makes a copy of all your data in Postgres, so you can do that stuff. So I talk a lot about trees. It's really a graph. The deal is Neo4j. They just got a couple $1 million in investment a few years ago. Actually, 2 years ago, somebody did a comparison. They built Graphicus. It only took them 400 lines of code to build a graph database, which means you have nodes and you have links. And they did some performance tests. It was way faster than Neo4j. But it's just one guy who did 400 lines of code. And so the productivity, the ability to just bring down your software development cost dramatically in ZODB is just huge. There are a number of different ways you can store your data. The simple one on the lower left is you have a single file and you store your stuff in a file. As soon as you get some big data images and stuff, you can store those images as blobs externally on the Unix file system. When you need more scaling, you have a ZO client server. So the ZO clients access the data from the ZO server, and the ZO server stores the data actually in the file system or on a blob. You can also do relational database storages using relational storage into Oracle, MySQL, Postgres, and if you want to do NewDB, you actually get a copy of all your data in PostgreSQL, so you can use all of the indexing things. ZODB has a more expressive syntax than PostgreSQL, so there's some things in ZODB you represent that you can't do in PostgreSQL. And so the way that to scale up, you'll have your clients, you'll have your node balancer, it comes into the ZO clients, and those all access the data from the ZO server, and they have a cache in there. And so the way the cache works is the objects that you're working on, each of the ZO clients has a cache, and if you update those objects, it invalidates the cache, it tells the server to invalidate the cache, and that invalidates on the other. So evidently cache consistency is a big problem in computer science, but I never worry about it, I didn't even know it was a problem. Scalability at Zope Corporation, they did hundreds of gigabytes of main data and terabytes of blobs, and if you need more, there's a cousin, very closely related library called Neo. That's not Neo4j, that's Neo, and they do 80 terabytes in production and 160 terabytes in test, so it scales happily. Security, the ZO clients and servers are all encrypted now, and what's really fun is this ZODB. So everyone's hosting in the cloud, and anybody can read their data, it's ridiculous. So what you do is you get ZODB off GitHub, and it encrypts everything and decrypts everything on the client. So the server has no idea what your data is on it doesn't even, it even encrypts the indexes on the client. So very fun software. For reliability, you can use Zope replication services to create a copy of your data. It basically does it for guaranteed message delivery from the primary to the secondary, so you can use that for reads. And you can easily imagine driving something like Elasticsearch or PostgreSQL copy with it, although that hasn't happened yet. Maybe internally in some corporations it hasn't. Okay, so I can talk more about the ecosystem, but before I sort of talk about the applications on top of it, it's a good time to stop for questions. Does anybody have any questions so far? Go ahead.
Just a little bit about the syntax. You seem to have a count -1. Is that just it's not a -1 thing going on?
Yeah, just no, there's no minus. It's a name, right? So it's a dictionary. Yeah, so there are two things. One is a dictionary, and you have to give it a text string, and the other is attribute name, and so that's just okay.
Right.
And I didn't actually test that code, but I think it was correct. Grab that out before.
So if you've got enough data in your database, it potentially won't get loaded. So how do you control uploads?
Yeah, excellent question. Excellent question. So,
can you repeat the question, please?
Oh, so the question is what goes into memory and what doesn't, what stays on the file system, right? And so what you do is you have a cache in memory of objects that have been recently used. And somewhere in the background, when you run out of memory, so the stuff that hasn't been used for a while gets released. I'm not exactly sure what the algorithm is. It doesn't bother me ever. If there's a problem, it's all Python. It's really easy for me to implement a different release from cache algorithm. There's an interesting thing when you first load the application, you may want to access one object and then access another and another and another. And so there's a way of just, when you first start up the application, bringing in the objects you wanted to cache. But, so yes, there is a cache release policy. I have no idea what it is. It's all Python. It's a couple lines of code if you want a different cache release policy. Any other questions?
So at what point does the persistence happen? At the point you commit the transaction, or at the point you mutate an attribute from the object?
Right, exactly. No, it's at the point exactly. So you have a cache of the objects, and when you mutate it, you change a dirty bit, and when you commit the transaction, that's when it gets written to disk. So your objects, during you commit like a transaction, things are happening, and they don't get committed until you actually say commit transaction, and then all the objects that have a dirty bit get written to the server. Any others? Okay, so let me talk about the applications of Plone, Flask, Pyramid. So the big one is Plone. It's a lovely content management system. You can see with the typical user interface, there's a view on the object inside, headers, footer, and you can display other information. Really brilliant content management system. I highly recommend it. but you don't want to be changing it, right? If you need to be doing custom application development, it's very old, tons of junk in there, not very flexible. The next one is Pyramid. There's some user interfaces, Substance D for bringing up content, but you know, they're totally on performance optimization, right? So big corporations, we want this thing to go as fast as possible, right? And that's one philosophy. And then what I did is I did actually development tools through the web, so I have a whole JavaScript development environment with HTML and CSS and JavaScript objects with nice editors. And I guess my philosophy is I want it to be as easy. You know, I don't care about computer cycles. I want to care if I have a problem, too much load, that's great. I care about real speed of development. So they're different philosophies. So the first thing to make it easy is you want to do CRUD. And the best CRUD that I know of is used in ZODB and it's used in CRUD and in Grok. And so here you have the iAccount object. So what you do is you define the interface for an account object, and you have to say, you know, what the description is and what the minimum value is and whether it's required. And so that's an interface object in the ZODB or Grok world. And then once you do that, you get all your credit for free. And the other thing is, once you have data structures like this, you don't even have to encode anymore. You can start to pull up forms where you add like an integer or float, and you just fill out the form, and then the user interface pops up. So, because every time I try to code it, I have to look and check the manuals exactly how to do it. So this is way easier. And of course, people build these applications with lots of views on any single node, lots of different views, and they can also have the URL, like the edit URL, could be the same on multiple different nodes, but you can actually use different view objects, and you can have different permissions, and some people can do this on that, and some people have permissions on the other branches, and it all gets very complicated. So you have to configure it, and there are a bunch of different ways of configuring it, but again, the Grok way is by far the easiest way. So here's the simple way to configure a view object. You just, you know, subclass of view and say what the render method is, print hello world, and your whole user interface is configured. Really simple because it uses inheritance to inherit everything. And a more complicated example, so if you want to audit an account, here we have an account object. You have to say that it implements the iAccount interface, which we defined a minute ago for the CRUD, and then you can have audit account view. You basically say, well, this applies to objects which implement iAccount. I use the URL audit, and they have to have the banking.audit account permission. So this all looks like it's just simple Python, and it took me a year to realize it's great for beginners. It's really easy to understand, you know, like decorators. But it took me a year to understand, and actually it's not what it's doing. What it does is when it first loads up, it loads that up and populates the configuration database. But in terms of ease of use, Grok is just wonderful. Okay, I'm going to skip these 3 slides. Let's just talk about application. And so the big thing is, my 2 competitors, Zeek and GLX, they both had like $3 million with 3 million euros of investment, 2.8 million euros. And their application is way worse because they're doing these directories, but they use a relational database. So they're like 2 or 3 levels deep. A basic factor in human factors is you only want 7 items in every category. So 1 level you can have 7 items, 2 level 49, 3 levels 350, or they put too much junk in there. And so I did it for like 1/20th of the cost. And parts of my tree for managing the Python taxonomy go 10 levels deep. And so just the productivity, the stories of the different people who've done really interesting projects. The GraphAGIS, Graph Database, the ZODB, the stuff I'm doing, just lots of stories of people building interesting stuff, you know, just sort of single-handedly. You have to ask, how do you compare this to other databases? Well, a lot of the databases don't actually do transactions correctly. A lot of them are not graph databases. A lot of them don't really do Python. So one of the things you can do in ZODB is you can add an instance variable at runtime to a single Python object. But you try to do that in a Java statically bound thing like Neo4j. I mean, I don't know, but I don't think you can do that kind of stuff. And then versioning is a really wonderful thing for any kind of content development stuff. Last piece of advice, Grok says, quit using Stone Age databases and go try the ZODB today. Thank you.
There's time for 1 or 2 more questions if anyone
So I didn't understand, what's exactly the relation between ZODB and ZODB?
ZODB is a fork of ZODB. They kind of all use the same code, and what they did is they added what you do in ZODB is every database access has to go through the client to do the decryption and encryption. So they're very closely related.
I thought the ZODB was actually relational, so they had tables and...
That's correct. So what they did is they put a relational model on top of the ZODB stuff.
Because I know ZODB and I thought it's a different model, of course, trying to understand how it relates.
Yeah.
Another question.
Go ahead.
The versions is essentially storing the whole copy of the previous object, or is like incremental changes to the object? So you know, as you change the object, you can either store the new version plus the old version, or store the difference in terms of attributes that have.
I think it stores the whole version. Right. And so what you also have to do is you have to do packing. So every now and then you pack the database and toss out all the, do all the garbage collection and clear out all the junk, but it stores the whole version. Yeah.
Any more questions?
Go ahead.
So I didn't quite get the relationship between CRUD, ROP, and ZODB.
Right, a very good point. So you have the I account, which is the interface, okay? And I account is an interface, and that just generates all of your CRUD, okay? And all of your CRUD, these are basically different views, right? And so the question is, which view, here's a good question, which view can I apply to which object? Well, if an object implements the I account interface, then the audit, the audit is on things that implement the I account. And so what you're doing is ZODB.interface tells you who has the interfaces, right? So,
right. But I need I need the presentation layer above all of that for us to look into, right? Or something. So
yeah, so you've got the tree of objects, but then you actually have views on it. Let's scan back to here. So on any node on the tree, you have all these view objects.
Yep.
So the URL, first it navigates you to the object, and the last segment tells you what the view object is that you should invoke. It doesn't actually tell you what the view object is, because for that edit, there could be multiple editors depending on which object, or for which object to use. So there's a whole lookup thing between that edit URL segment and the object class and your permissions and which view is invoked. And all that stuff just works perfectly. It's got inheritance. It just does the right stuff. It's just gorgeous. I mean, there's some people who think that these things are so brilliant. How did they, I couldn't have invented them. I'm not smart. Very, very good stuff.
If there's no more questions?
Yeah, if you want, I'll do a quick, go ahead. If you want, I'll also do a quick talk on the maps of companies.
So what's the actual storage format on this or whatever? I mean, I understand there's backup storage, but do you like use SQL in storage on this, or how is it?
Yeah, so let's go back to.
So I guess the relational database ends up as columns, right?
Right, so you got different ones you can store. So if you store it in a relational database, you have an object ID followed by the content, by the pickled content. So they take the Python object, they pickle it, right? And that's why it's much more expressive than other things, because anything that you can pickle, whereas most relational databases won't take anything, right? So you've got when you store in a relational database, you have an object ID and you have the pickled content. When you store it on a file storage DB, what they do is they write to the end of the file, and so you have, every time you have a transaction, all of the objects which are written, modified in that transaction, are all clumped together and written at the end of the file. And then you have an index that says this object is here, this object is here, this object is here. And so then when you pack it, it updates the index and squishes that all down and tosses out the garbage. Does that answer your question?
Yeah.
So I think you will offer a talk about the companies in London.
Yeah, and the Python mix. I did the lightning talk last night, but a lot of people weren't here yesterday, so I'll just take 5 minutes.
But we'll say thank you for the main talk here, Christopher.